The following presentation was recorded at the 2025 Southeast Linuxfest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information on the Southeast Linuxfest, visit www.southeastlinuxfest.org. Come join us next June.
All right, it's 5. We'll go ahead and get started. All right, so I assume if you're here, you've heard of Nix. Who has used Nix? Okay, who's kind of curious? Okay, who's skeptic? A couple people. Okay, cool. So I'm Allie. I'm an occasional contributor to NixOS / Nix packages. That's our huge mono repository on GitHub. It has every single package and module that is in NixOS. I do mean occasional. I'm not trying to oversell myself. I mean, I fixed a couple bugs here. I've been using NixOS for about 3 years, and I came to NixOS because I was a little totalitarian, let's just say. From the beginning, I wanted a system that was exactly what I wanted, nothing else. Started using Linux in about 2007. Started self-hosting about 2008. It was an old ThinkPad that I had like under my bed. It was a tablet too, so one of the X31 or 41Ts, and it just kind of lived under my bed, ran the worst, least traffic WordPress server ever. And then just with a couple, friends and stuff like that, I started building distros about 2009. They were mainly just, you wouldn't have heard of them. Let's put it that way. Talking about like Ubuntu derivatives, things like that. So I was already kind of in that headspace. And then I just started writing package managers for fun. So, why? Who knows? Like I said, I'm a little bit totalitarian about it. I want it to do exactly what I want it to do. And Nix is perfect for that. And especially when you've been hosting for, especially self-hosting for, I guess, 17 years now, which makes me feel ancient. You kind of know server maintenance feels like this. And sometimes hosting a server, especially one in your home where you got power outages, you got people who just unplug it for some reason, you're using consumer hardware, so everything's already a little suspect in the beginning. You will have these nights or these weekends or these week-long sort of like, well, nothing works. I guess I'll just turn it off and try it again later. And we all kind of know how this problem goes, right? Stuff breaks. Sometimes you don't even know it breaks. Sometimes you don't know it breaks for a week, especially if it's just the server that's living in your closet, right? You might know how to fix it. You might not. You might not remember how you fixed it. And then when you do figure out how to fix it, now you've wasted all this time. Say, for example, let's just yell it out, honestly. If I just deleted your boot drive on your server, how fast could you get it back? Assuming, okay, I'm giving you a new SSD, and I'm just breaking your old one in half. How fast are you back up and running? 24 hours? I've done this test. I was back in about 20 minutes. So we kind of know what we need to reach that sort of 20-minute or less, sort of like, let's just figure it out. It's all set up, right? You need to be able to rebuild everything from scratch very confidently, right? Not like it kind of looks like it's running the same services. No, you need the same configuration. You need the same data. You need all of that, right? You also need to be able to come back to it in a year or two and know what is going on, right? You also probably want version control. You want some control over how did I do that before? How am I going to do that later? You want some record, and you want some way, some source of truth to it. And like I said before, you want to be able to do it now, tomorrow, next year, 10 years from now, hopefully, right? This is what we have, typically. There's a couple others. There's a lot of others, but they kind of fit these categories, right? You got bash scripts, you got Ansible, and sometimes Ansible is just bash scripts. And you also got Docker, which, spoiler, is also just bash script sometimes. So bash. There was an excellent talk here last year about debugging bash. It was intense. Why? Because debugging bash is difficult. It is not an easy language to write in. It's not an easy language to debug. If you've gone more than, say, 50, 100 lines, who knows what's happening, right? Anyone just sort of like, oh, I've got this bash script. It just kind of, like apt-get installs Plex, and then it kind of just, does all the things I need. Yeah, it's kind of your starting point. That works great until, the Plex repository no longer exists. It's going to break eventually. You also have no built-in rollbacks. If you're rolling it back, you're figuring out how to do that manually. And like I said before, you're the one installing all the packages. So Linux package managers have gotten really good at this, but still, if you want a WordPress server, well, you probably also want, some sort of server or some sort of database server as well. And you have to pick which one you want. You have to set it up, blah, blah, blah. It doesn't come already like that. Ansible's kind of similar, but it does take a step towards what we're kind of looking for. It at least looks sort of declarative, right? But it's not really deterministic. The final system really depends on where you are right now. And if you don't control that base system, or if something in that base system has changed, you will not get that same final output. You might be able to do that manually, but it's not going to be automatic. And if you do need to roll back, it has some things to help you. You can rescue, but it's not exactly foolproof, right? Also, YAML sucks. I don't like writing YAML. I don't think anyone does. Now, Docker. Okay, most people are probably using Docker to host applications, especially at home. I'm using Docker as well, spoiler. It's really great for applications. That's fantastic, but you need something to run those Docker applications on. You need some sort of base OS. And when you do build a Docker image, you're relying on these base images that might change from one to the next. And that's really just because Docker files are just bash scripts kind of in disguise, right? You're just going through the motions. Well, Nix is here to save your day. All right, so there is a lot of confusion about what Nix is. And that's because Nix is like 10 different things. It's a package manager. It's a language. It's Turing complete. You can write any sort of recursive expression that you want. It's also a build system, so it can be used to build, compile packages. It's also a Linux distro. And it's also this massive package repository that, for some reason, we keep in one single monorepo on GitHub, which has advantages, of course, but it's disadvantages when it takes like 20 minutes to clone it. So, with that in mind, just to understand what Nix is, what Nix does, when you're working in this imperative mode, like a bash script, you're going through the motions of what you need to install, how you need to configure something. Here's how it's, here's what you need. You're building it based on that. With Nix, you're not so much giving those steps. You are describing how the final product is going to look. And everything else is abstracted away from you. So sometimes, spoiler, it will run a bash script, right? But all of that is abstracted to you. And all of this is living in the Nix store. So everything you build with Nix is living in this immutable hash store, right? And then symlinked everywhere. So if you hate symlinks, I'm sorry. So this has some advantages Because every path in the Nix store is hashed, if you get the same inputs, you'll get the same results. You will know if something changed. You also have atomic generations. It's very, very easy to roll back. Certain things like Fedora Silverblue, Bootsy, those things, they do allow you to have this sort of atomic process, but usually you have to stage updates and then you reboot. Nix, you can do that live. It will rebuild the entire system on the fly. And you're working with pretty simple tools. NixOS rebuild, and you can use Nix files. You can just use Nix files with what was called channels. Those still exist. Those are still the default. But we're going to talk about flakes. So anyone heard of flakes? Okay. Anyone understand flakes? Not understand flakes? Okay. So these are flakes. I love this image so much. There is a source in the presenter notes. You can check out the slide online. Give that person some credit. So flakes are a very standardized way to define and share Nix projects, right? You define your inputs. You have some logic to it. You have some declaration. And then you have these outputs. And it's all locked by hash to your flake.lock file, right? So what that lets you do is you know that if it works on one machine, it's going to work on the other. Because Nix doesn't depend on any of the environment. It builds itself. It checks to make sure that everything is identical to how it was when you made the project, when you made that lock file. So this means that those results can also be cached locally, remotely. You can actually push them from one Nix store to the other. So if you build once, you might not ever have to build again. But you probably should, because you'd probably update your projects every now and again. But what this does is it makes Nix this composable, shareable, and reproducible by default system, right? Both if you're running it for any sort of arbitrary package, so if you're using it to package something, or if you're dealing with your entire NixOS configuration, because Nix also runs on non-NixOS distros. So what are inputs? Inputs, other flakes, that's the first thing. They can also be any arbitrary path or Git repository. Doesn't have to be a flake. It will still hash it to that revision. So you're never going to have an issue of any sort of drift in your inputs. You can also use local directories. I wouldn't recommend that, but some people do relative paths as well. And then you have your outputs. Those can be packages, development shells. Those are reproducible development environments. So say you got a project and you know you need Node.js. Well, throw it in the dev shell. Everyone who uses that Nix file will have access to that environment, exactly how you define it. You also have NixOS configurations. That's the whole operating system. Home configurations, which use a similar project that's pretty tightly integrated called Home Manager. You can run that on any Linux distro. You can also run it on macOS. And you can also share configs between macOS and Linux if that is of interest to anyone. And then you have modules. That's just a standardized way to share reusable Nix code. So if someone writes a module, let's say starts a service for a torrent client. Well, maybe it's not in Nix packages yet. You could use their module, have it as an input on your system, use the module as you wish. So if you go to the command line and say Nix flake show, it will show you every single output of your flake in this very structured way. This isn't a abridged version because mine would take like 4 PowerPoints slides to fit. Got your dev shells. You can define them differently depending on which architecture you're on. So this is for x86-64 Linux. You got NixOS configurations. Those are unlimited. You can define as many as you want. Modules, exactly what I said before. And then you've also got packages, right? And you can use overlays with packages to pretend like they're in Nix packages, which has some advantages. But You can see here, deployer, that's a deployment tool I wrote. Formatter, that's just my formatter. I just wrote a wrapper around all the languages that are in my flake. Very simple. And in terms of what a flake looks like, hello world. So this is a flake. It takes in Nix packages, the unstable branch. That's its sole input. And then as an output, it will give us the GNU hello package. It's hello world. You can even build Docker containers. So this is the same concept, except with an OCI container as the end result. And here's a very, very trivial NixOS. So we've defined our bootloader and where we're going to install it, our root file system and what file system type it is. We got OpenSSH, and we've also got a dummy root password. So theoretically, you could spin this up. It would probably work in a VM. And then you can SSH into it. Oh, also, these slides are available as a flake. That's how I've been developing them. Very simple. We had the build phase. Use an awesome tool called MARP. I've seen a couple other people using it here itself. This just basically makes it really easy to use Markdown to write slides for presentations. MARP just compiles that into an HTML file at the end. So you got your build phase, install phase, and then we've got our build dependencies, all sort of just declared. Though I will say clearly that is just bash. All right, so in terms of how you interact with Nix, you've got the Nix CLI. That's the main, there's not really, there is a sort of GUI package manager that looks like GNOME software, if you want to figure that out. But the main way that most people are going to interact with it is on the CLI. So it's very simple. You can build outputs. You can launch a dev shell. So if you cd into the directory of a flake and you run nix develop, it'll just put you in that development environment. You can run nix flake check, which is really, really important because it means that it will evaluate your entire configuration, make sure there are no errors, right? So not just that it's valid Nix code, but it can also catch certain things like, hey, you're trying to install this program that's only available on ARM64, and you're trying to install it on x86. Simple things like that provides a lot of insight into, oh, why am I getting that wrong? And you can also run Nix Flake update. Very simple way, updates all your inputs. And then you run Nix Flake check, figure out, oh no, something's broken. And then you run Nix build, oh, a lot of things are broken, sometimes. If you're on unstable, that's how it's going to be. This is what it looks like, just on the command line. I built, you'll notice this is, I'm building an x86 config, but clearly that's a Mac. So we've got, one second. All right, so we've got our Nix build command. What that'll go through is it will literally assemble the entire operating system as it should look like, and it can also do it remotely, right? You can do it on other systems, so you can build once, deploy it anywhere else. And then when you run Nix Flake check, you'll see there's some warnings here. Hey, these are things you should probably know. If it does find errors, it will just stop, and it'll let you know what the problem is. When you're using NixOS in particular, you can use NixOS rebuild. That's probably going to be the main way. What this lets you do is instantly switch between generations. So unlike, as I said before, other immutable distros like Fedora Silverblue, that kind of thing, you can actually switch immediately. You don't need to reboot. You don't need to stage it. You can do it immediately. And what it will do is it will run through and do a best effort to bring your system into that state. If there's a kernel upgrade, well, can't really do much about that, but it will restart services, stop services, start services as you need it to. You can also do interesting things like you can test. So if you run NixOS rebuild test, what that will do is that will switch to a generation, but it won't add that to the bootloader. So it's ephemeral. So if you wanted to test something, make sure everything worked, but you weren't sure about committing it yet, perfect. You can also do the opposite, where you can stage it for the next boot. Sometimes that can break things, especially, for example, I use Tailscale. And so when I'm updating my servers, Tailscale restarts. All my networking goes down, it just closes, right? Don't want that, do need a reboot for that. You can also build VM and cloud images. So you can actually build for, say, GCP with NixOS rebuild. Just automatically, it'll do all that for you. You can also create live images very easily. So you can create like a minimal environment that already has your authorized keys in it, and then you can just SSH into it. Very simple. And then you can also use this to deploy to or build on remote machines because Nix is inherently distributed. So actually, if you look at this, you can see it evaluates your flake first, builds the system configuration. In my case, this decrypts my secrets, which are stored in age in a public repo, but only I have the keys and only my hosts can decrypt those. So just basic things like passwords, any sort of like machine sort of secrets that you might need. Then it will symlink everything together, sets up all your Etsy files, and restarts and stops the services as needed. And then finally, at the end, that's your store path. So that is where your entire system is contained. Okay. So what Nix lets us do is essentially just get ops fully realized for Linux operating systems, right? You can evaluate before you build, you can build before you commit, you can test before you merge, and then you can commit before you actually deploy. It really just brings all of that together in a way that other solutions don't get fully there. And that's a great segue into how I actually use this. This is my Homelab. It looks like crap. It's on some IKEA furniture. So my Homelab, it's 7 NixOS servers across 3 data centers. One is my house. One's on Hetzner, one's on AWS, sometimes 2's on AWS. We got 4 laptops. So that's me and my husband's laptops. He's right there. He's my guinea pig. They're all running NixOS. I also have a MacBook. It runs a Nix Darwin, which is a similar project. If you have a MacBook, you'll really like that because it can essentially as close to NixOS as possible, but on Darwin. So you can manage things like services. That's how I run Olama on my MacBook. It's really simple. I've also got 3 architectures, which is a pain. But Nix does make it pretty easy. And I've got 5 users. Some of those are just, depending on how you define user. Some of those are people who watch the Plex server occasionally. Other people are, people whose devices I manage, that kind of thing. Also, all my devices, I don't know if anyone noticed, but they're named after places in Pokemon Ruby and Sapphire. So, nerd. So what do I host? This is a not exhaustive dashboard. This is with Glance. Glance is really awesome. You just build simple dashboards. It's not really like a monitoring solution, but it does give you like a browser homepage type aesthetic. Got Plex, Ombi, Image, Karakeep, which I've recently discovered is absolutely awesome. It's like a bookmark hoarding thing. You just send your bookmarks there. It can use AI to automatically label them. It's really, really great. Vault Warden for JO, and also all of my action runners, those types of things. Also runs my website that these slides are currently running on, all of that. Also, my Blue Sky is posted from here. So, long story short, okay, let's get to it. how I use Nix to not break things. Spoiler, I do break things. But the first is reusable infrastructure. I've got probably about 10,000 lines of Nix by now. And that's really just because over the past 2 years, I've just made it my best effort to, anytime I'm writing a config, I'm going to write it in Nix. If a module doesn't exist, I'm going to write the module. So that can be a pain, but it's a pain once. So everything like apps, settings, services, bootloaders, kernel modules, fonts, Wi-Fi networks. So I do manage Wi-Fi networks declaratively with Nix, which is really great because I'm really bad at remembering, and I absolutely hate when like one machine has one Wi-Fi network and the other one doesn't. I switch laptops a lot. And the great thing about this is that those 10,000 lines, yeah, it seems like a lot, but a lot less is actually running on each host, right? Because Nix has a very, very nice options system. So for example, this is my personal website. It runs as a Docker container, mainly because full transparency, I haven't figured out how to make Hugo play nice with Nix. It has submodules, it wants access to the internet, and Nix is like, no, we're not doing that. But it's very easy to run Docker containers. If you notice, this looks very much like a Docker Compose file would, except we've got some options here. I could choose which port it runs on. And more importantly, I can reference that port later when I have my reverse proxy, right? It will actually pull that exact port, and so I never have to change it in 2 places if I do change it. I've also got a very complex CI workflow set up, mainly because I can. Not saying you need to, but I can. Every push triggers checks for evaluation, formatting errors, standard stuff. All my flake outputs are built automatically. And so if there is a build error, I'll know. And all of those build artifacts are cached. So anytime you're writing a config file, Nix treats that as a package. And so if you don't have to write that config file again, it's going to save time, especially when you're working on really resource-constrained systems like tiny AWS VPSs, that kind of thing. It could be really nice to just push all the files to it. It doesn't have to do anything, doesn't expend any resources. It's just there. I also update my flake.lock just on a schedule, runs like twice a week. I wake up in the morning and it's just there. There's a pull request waiting on me. Usually it succeeds, sometimes it doesn't. But if it doesn't, then Nix usually is pretty good at telling you what broke. I run unstable. It can be kind of questionable sometimes. But you can run stable. Stable is very stable. It's twice a year. It gets very, very little updates outside of security. And yeah, so nothing is merged until it's actually passed this process. So even though I'm running this very unstable rolling release distro, well, I'm not going to merge something that's going to break my whole setup. And if I do, then I'm just going to get reverted, right? Because I also have automatic deployments. There are tools to where you can have it to where in actions or CI type pipeline, it can just automatically push it to your systems. I don't really like any of those. I just settle for automatic nightly updates. That's the best, because otherwise I'd be updating it constantly all the time. So basically every night, all of my servers, they pull down all the dependencies they need from the cache. And then any builds they need to do are distributed. And so, for example, I've got a pretty beefy server at home. Like not crazy, but it's, pretty powerful. I'm going to prefer that than using a laptop. Or I'm going to prefer that than using something that I'm going to have to expend like CPU credits for, right? Or something that, one of my devices is a 10-year-old Think Center that I've just repurposed as a server. yeah, I don't want to be doing any building on that whatsoever. And also, this means that when I do deploy manually, I typically use NixOS rebuild test. So nothing actually hits the bootloader, and the only things that are hitting the bootloader are things that have actually passed CI. I know that they work or have a reasonably certain guarantee that they're going to work. Sometimes you do have things that build but also break, but that's somewhat rare. And here you go. This is just my automatic upgrade config. It's actually just a wrapper. I didn't have to write my own module. I just kind of wrote through my own settings. This is built in to Nix packages, to NixOS. So you can set it up. You can set up reboot windows. So you can allow it to automatically reboot, but only if it needs to, right? So it'll actually push itself to the latest version. And then if it's like, oh crap, well, there's a new kernel version, it'll reboot itself. So it's pretty smart. And then I also have declarative backups. And these are on by default. I just have a Nix module, and if it detects that I have enabled a service that I've written a backup module for, it'll just back it up. Max it up to Backblaze. Backblaze is super cheap. You know, I never have to worry about not having backup. Also, just it can interpolate strings. So for example, the host name. So every machine, this is actually running different code. So on every machine goes to its own place. Also, it's using Rustic. Anyone used Rustic or heard of Rustic? It's pretty good. It can also, it both encrypts it and also prunes older updates. So I'm only keeping a certain flow of them. And then that means that if I do break things really bad, which I have done, I've also have, you know, the normal things like hard drives failed, blah, blah, blah. It's pretty easy to get it back. I install Nix. Because I have everything cached, that only takes like 5 minutes, and then I'm in a bootable state again. And I just run a command, restore the backups. There we go. Here you go. You can see a couple snippets of what this looks like. So for example, for CouchDB, it knows to restart the service. So I try to do it cold when I do these backups. I just don't want anything changing while I'm in the process of backing it up. So I'll stop the service real quick. It pushes it to Backblaze, restarts the service, and it's seamless. So this is a lot to set up, and I'm sure I've probably scared people. But there are some rewards, right? One is just the decrease in sort of cognitive load. Like all of this stuff is just kind of thrown up into my Git repository, and I never have to think about it again, right? Even if I'm no longer using a service, like say I decide I want to use 1Password instead of my own Bitwarden, well, in 6 months, if I decide that was a mistake, I haven't deleted the module. The module's just turned off. I'll go back and I'll be like, okay, cool. I'll do this again. I don't have to figure out how it works. And it also just means that I could just like write this one time and it just deploys forever. And anytime that there's an update to these modules, because sometimes there are breaking changes, you get ample warning, right? Nothing has changed immediately in Nix packages. It usually takes several stable releases for something to be truly removed. And some things are technically deprecated, but probably will never be removed. And it also means, like I said at the beginning of this talk, I can just nuke and pave all my servers anytime I want, right? It's not really a concern. Could probably do it in 10 minutes, depending on the server. Might be 30 minutes for some, but it would be very easy to do it. So if you are still interested, next steps, pick a Nix. This is Linux open source. That means there's going to be forks, and there's going to be forks with the fork, and there's going to be controversies around the fork. There's going to be hostile forks. There's going to be nice forks. There's going to be a lot of drama, right? So CPP Nix is the default Nix implementation, or rather the first Nix implementation. It's written in C++. The main problem with it is that it's kind of been in a deadlock for like, I don't know, 5-10 years. There are merge requests that are 5 years old that probably are ready to merge that just haven't for whatever reason. So there's 2 different forks, of course, right? You don't need to know about that. You don't need to use a fork, but if you are interested, and especially if you're interested in running Nix on a non-NixOS environment, so on another Linux distro or on macOS or on Windows, you can also run it on Android, by the way. There's Nix on Droid. It's really just managing your dot files in a terminal emulator, but it's something. You've got determinate. That's kind of a more corporate defense contractor affiliated fork. Let's just put it that way. They do have excellent documentation. They are a little shady on that though. So there's also a community fork named Lix. You can install Lix. That's the way I'd recommend to install it if you're not on NixOS. Because the default installer is bad on other distros. It's just bad. Don't do it. And yeah, Q&A. I know that was a lot of info dump, kind of all over the place, but would love to hear any questions. Also, that's my website. Anyone hiring, let me know. What's that? Questions?
Thank you. Okay, a couple of questions about flakes. First one, I think this is true, but correct me. Are flakes additive?
Define additive.
In other words, can you have multiple flakes applied to the same Nix instance and have additional configuration outputs?
For a NixOS configuration,
Yeah.
it's 1.
Okay.
But since flakes have tons of other outputs, you can run a flake at any time.
Okay. So it's not anything analogous to like roles for Ansible where you could have multiple, additional processes added.
No,
So
you can
the
do
one
it with
flake-
modules, but you have to do it ahead of time in the same
So the one
repository.
flake has to apply to whatever systems you're at.
Right.
Okay. All right. And that kind of answers my second question on it. Actually, it redirects to another question. How detailed in terms of service configurations can a Flake or NixOS configuration get in terms of, like, say, hardening a system, configuring, your config files, etc., things like that?
So anything that systemd exposes,
Yeah.
you can write a config that will do that. You can write a service config. There are modules that are pre-written. Those are usually services dot blah blah blah, like services.plex.enable if you want a Plex server.
Gotcha.
That's what you'd enable. But on the back end, what that's really doing is systemd.services.plex, and then it's the same as a systemd unit file.
Okay, so you wouldn't necessarily be able to template config files or anything like that.
You can,
Okay.
but you kind of have to roll your own. I've done that a little bit. If we go back, if you see config.mysnippets.restic,
Okay.
I really just want the same thing over and over again, but I kind of want it to be configurable. So maybe on one host, I want slightly different backup options, but I want them to apply to everything. That just merges the attribute sets.
Okay.
And so what's in my snippets.restic is kind of a template of like a starter config, right?
Okay. All right. Well, thank you.
You mentioned earlier the ability to build VM images and cloud images. With that, can you also build Docker container images?
Yes. So you can both have a Docker. There's actually one here. If we go back. Yep. This is a hello world. You can also build like more complex, like layered images and stuff, but this is, I didn't want to just have a ton of code on a slide. But yes, you can build Docker containers. You can also run them. So it's kind of like Podman Compose. On one hand, there's kind of two different sides. That's a NixOS module, but built into Nix packages, you can also build those images.
You mentioned you had less like load on your AWS from using Nix. How much are you like saving, or I guess yeah, how much are you saving, or how would you like I guess kind of scale how much you're saving?
For me, I'm only really using one AWS instance at a time, and so it's kind of usually free tier. But I'm going to be honest, if I couldn't do it like this, then I probably would have upgraded my instance by now. Because if I have to manually handle like updates and it's like just hitting the CPU and doing all of that, I would prefer it not to. This just means that all of that evaluation doesn't need to happen. And Nix does, as you can imagine, take a good bit of RAM. It can run on systems as low as like 256, 512 megs, but it's gonna be slow. So yeah, this is definitely like, it saves resources, definitely saves like vCPU credits and things like that. Build time. So when it has to evaluate your configuration, and then it builds it. And so after it's built, it's just like any other Linux distro. There's nothing special about it.
What's the cost of implementing this? Like time investment. Let's say I'm like on traditional, way, and I want to shift to this. Like, how many hours do I need to sink into this?
I think that depends on where you've started. I think that Nix has, also apologies, I'm losing my voice right now. A lot of people who start with NixOS are kind of just don't necessarily come from a sysadmin type background. For them, and especially even sysadmins that maybe don't have development experience, I could see how it could be pretty difficult. But if you're used to other things like, I mean, honestly, even if you're used to things like Ansible, like it's not that hard. If you also are used to things like functional programming languages, that's pretty straightforward. Nix is functional. It's basically like Haskell that kind of looks like JSON, which is some people find very ugly. As far as just time investment, I think it just depends, really. It really just depends on your background. For me, I kind of like tried it, bounced off of it, and then I was like, all right, well, I'll come back and I'll try it again, and then it finally clicked. And so that was just like, figuring out the landscape, maybe a couple dozen hours, and then I was in. It also helps that if you are configuring your system with NixOS like this, you don't have to do everything in Nix. You can still do things manually. And so, like someone like me, like I manage like my Firefox profile with Nix. You don't have to do that. You probably should not do that. Especially in the same flake where you're also managing this very large Homelab, right? And so it really, you can take it in this piecemeal way. You don't have to take all of it. If you're more of a software developer, I think it's pretty easy to get started with building development environments, building flakes just for packages, and then working from there. Got one more right here.
You you had said that the language was declarative. Is it is it idempotent also?
Yes.
Okay. Okay.
It will do the same thing every time. And in fact, because the build results are cached, if you run the same config over and over, it's near instant. Like if you ran it from nothing, it would be a while, depending on what you have, obviously. But for making, say, a minor change or running the same config on, say, this laptop, which runs NixOS, we're talking about seconds. And it's exactly the same as it was before.
Okay. You just actually spurred me to another line of thought. Is my understanding was it was pretty declarative in terms of, getting it to a desired state, but I take it as not necessarily immutable once it hits that state. For instance, could you use an additional configuration tool along with it when I'm getting back to that like templating files thing I was talking about?
You could. You could theoretically use something like Ansible on top of Nix. The other NixOS Homelab presentation talked about doing that. So you can. But there are some caveats there. So certain things really want to be done the Nix way.
Right.
That just depends on what you're doing. But you can still, I mean, theoretically, you can do what you want.
Most of what I'm thinking about is things like I said, like hardening your SSH profile, or once you get your Nginx or Apache set up, dumping all your confd, as needed and so forth. Or if it needs to be dynamically determined when you're dumping it based on the target site or something like that is what I'm thinking of. So
Yeah.
like you could Nix flake to get it to a certain like profile point, and then at the very end trigger an Ansible playbook or role to configure, the individual applications config files and so forth.
Yeah, I mean, so if you're saying like Nginx, usually that's going to produce something that's symlinked from the store, and so that is immutable. But there are often ways around that.
Okay.
So for example, it might be like an immutable config file that imports something that is user generated that is not necessarily in the store. So there's a lot of sort of like back ways around that. But generally speaking, you do want to do it the Nix way. Thank y'all.